I have been fighting this PnP machine for weeks. Today, it faces its first real challenge, assembling the SatNOGS Encoder. If this goes wrong, a lot of my upcoming projects stall. So let's find out whether this thing actually works. I have been working on this pick-and-place machine for weeks. Today we're finally going to try it on a real board, the SatNOGS AS5601 encoder. And honestly, everything I'm preparing to build right now depends on the PnP machine working. In the past, I have used many offshore assembly services, but between fees, shipping, and the 50% tariff applied to parts and assembly, they have become expensive. Assembly service can also easily add a week or two to the delivery time. For prototyping, an assembly service does not align well with an iterative build and test workflow. Manual assembly, on the other hand, is fine for single boards with 5 parts, but it's tedious for small series or boards with 200 plus components, especially if they contain 0402s and the occasional 0201. So I need affordability, repeatability and reliability, faster iteration, and the ability to run small batches as I plan to sell some of my boards to you. That's how I ended up with the MicroSMT, an open PnP compatible kit in the $700 to $1,300 range. I splurged on high-wind rails, belt tensioners, an upgraded vacuum pump and auto feeders. The MicroSMT features a compact footprint, an active community and a responsive company. It just hit the price-performance sweet spot for me. Now it just needs to actually work. Building a PnP is a bit like assembling IKEA furniture, if IKEA required a 3D printer and a tolerance for redoing things 3 times. While MicroSMT provides step files for all 3D printed parts, I redesigned more parts than I initially expected. I added feet to the frame. The bottom camera diffuser came in 2 parts, so I merged bracket and diffuser into 1 part. The auto feeder controller sat too low in its bracket, so I raised it. The main controller board was too close to the extrusions, so I lowered it and braced up the mounting plate. And the original nozzle cover was impossible to print cleanly, so I rebuilt it in Fusion 360 with a printer-friendly chamfer instead of the difficult-to-print roundover. The nozzle holders were their own saga. I need the PCBs to be mounted 15 mm above the base plate, which meant the original holders were too short. I extended them. Then they were too thick on top, which prevented reliable nozzle changes. I thinned them down. Then the nozzles tipped inside the holders because the thin tops cannot steady their nozzle tips. So I redesigned them yet again with wider shelves. And then there are the cables. A dozen wires and hoses all need to run through the drag chains. To keep them from tangling, I sleeved each one in braided nylon secured with heat shrink tube at their ends. And just when I thought I was done, the build surface became the next problem. The stock build plate for MicroSMT is beautiful, 3 mm flat black anodized aluminum, but it's not drilled, and it's not magnetic, and it doesn't support dowel pins nor magnets for repeatable fixturing. For my workflow, that wasn't going to cut it. So I designed a new build surface, a 3 mm magnetic steel fixture plate with a grid of holes for dowel pins or screws to attach and locate mounting plates and feeder trays. I ordered the plate from a sheet metal service and then noticed that I made a classic mistake. On the drawings, I swapped the hole sizes. The grid holes were 4.5 mm, the mounting holes were 4.0 mm, exactly backwards than intended. Too stubborn and too cheap to reorder, I sanded the plate, primed and painted it, and mounted it anyways. And honestly, it works great. Magnets hold down feeders and PCB plates beautifully, while dowels locate them repeatedly. MicroSMT provides config files, but for an older version of OpenPnP. Instead, I downloaded the latest version and started from scratch. Homing immediately crashed the head into the frame. Backlash was terrible. Camera calibration took hours. Nozzles crashed into their holders during changeovers, and nozzle runout was its own adventure. After days of tuning, I reached the moment of truth. There was nothing left to calibrate. It was sink or swim. The SatNOGS AS5601 encoder is perfect for the first job. 6 components, small but not microscopic, and genuinely useful to track spindle orientations. I even had the PCB manufacturer penalize the boards, 90 units for almost nothing. If the PnP works, I can build a series of these for the SatNOGS rotator and other projects. Let me know in the comments below should you be interested in purchasing some of these boards. I use simple strip feeders pinned to the fixture plate. The MOSFET placed fine, until the vision system refused to detect orientation. I discovered the recycle back into the tape pocket feature, which is adorable, in theory. Except the MOSFET refused to drop. Even with the vacuum off, it clung to the nozzle like a barnacle due to static or dirt. I had to touch it with the tip of a knife to make it fall back into its tape pocket. Then the main chip wouldn't be picked up at all. The nozzle was hovering 2 mm above the part because I outsmarted myself when I adjusted the feeder's tape height for chip thickness. One quick configuration fix later, we have perfect placement. The 2 resistors, smooth. The first capacitor, smooth. The final part, the second capacitor, PnP insisted that no valid feeder existed. The culprit, clear tape. The feeder pipeline couldn't see the holes and thus failed to locate the capacitors. I turned off the vision pipeline for this pickup and all worked fine. So after a full afternoon of fun, all 6 components were finally placed correctly. Time for reflow. Chip quick Type 5 paste, a syringe and my little heat plate. Of course we're breaking the linear timeline here. I applied the solder paste to the PCB before I mounted it in a pick and place machine. But starting the video with me applying paste would have broken the narrative flow. I can never get enough of seeing solder paste turn into a liquid. Anyway, just as the solder reflowed, I forgot how the heat plate buttons worked. In panic, I pulled the plug. But the board looked good. Continuity checks passed, and the final test, reading register 0 returned the expected 0 value. It worked. The PnP machine survived its first real challenge. Now I only have 89 more boards to assemble, and then we can move on to the next part of the SatNOGS project. Thanks for joining me at 4111 Spyglass. See you next week.